Okay, in this video, I'm going to be showing you how to find the prime factorization of a number and how to use prime factorization to find how many factors a number has. Okay, so for 432, we have to break this down into numbers that are only prime. So we know that 2 is one of the factors because it's an even number. So inside here it goes 216. Because 2 times 216 is 432. And if you know your cubes, you know that 216 is 6 times 6 times 6. Let's write that down. 6 times 6. But we're not done yet because 6 is not a prime number, so we can reduce that further. 3 times 2. And since we have 3 of those 6's, we can cube this quantity. Okay. And we're going to be left with 2 times 3 cubed times 2 cubed. And notice how we were able to distribute this exponent of 3 only because we had multiplication on the inside. If this was 3 plus 2 to the cube, we could not distribute it because it would not be true. Okay, so here we have like terms, so you can group those. So we have 3 cubed times 2 to the fourth. And that's our prime factorization. Okay, so counting factors. A is a factor of B if A divides B evenly. So that means that 100 is a factor of 200 because 100 divides 200 evenly. And we can use this concept to try to count the factors of 432, but it would take way too long. Like we could try, okay, I know 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor, but you keep going on and on and on, but it's gonna take too long. So if you've seen the last video, you know that tables are great for these types of problems. You see here, if you create a table with 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, and the same up to 2 to the 4, we can generate every number that's a divisor of 432. And if we want to count these divisors, we just want to find how many squares there are, which is going to be 1, 2, 3, 4, 4 times 1, 2, 3, 4, 5. Okay? And notice how we have to add 1 because this is 3 plus 1 times 4 plus 1. And 3 and 4 were our original exponents. And the reason we do that is because we have to account for 3 to the 0. That's the reason we added 1 to these original exponents, 3 and 4. We added 1 to each. Okay, so that means that 20 is how many divisors 432 has. That's our answer. Okay. So you see here, to count factors, we have to add 1 to each of the exponents and multiply the exponents. Let's do one more quick example. If we have 2 cubed times 3 squared, the number of factors is going to be 4 times 3, which is 12. Okay, next one. How many positive integers are divisors of 21 to the 75th power? Okay, so we can break down 21 into 3 times 7 to the 75th power. And what we learned from the last problem is that we can distribute this. So we have 3 to the 75th times 7 to the 75th. And since these are prime numbers, all we have to do is multiply now. So the answer is going to be 76 times 76, which we can quickly check that. 76 times 76 is 5,776. That's our final answer. So 21 to the 75th has 5,776 factors. Carlana places 600 marbles into M total boxes such that each box contains an equal number of marbles. There is more than one box and each box contains more than one marble. For how many values of M can this be done? Okay. So this problem really is asking how many divisors divide 600, but we have to exclude 601. 601, these cannot be counted because there has to be more than one box. So there can't be just be one box with 600 marbles, and each and that each box contains more than one marble. So we can't have 600 boxes of one. Okay, for how many values of M can this be done? Okay, so we're going to find the number of divisors of 600 and subtract 2 to account for these divisors that don't count. Okay, so 600, that's 6 times 100. I know 6 is 3 times 2, so let's write that down. And 100 is 5 squared times 2 squared, because 25 times 4 is 100. Okay, now we can group the like terms. And we get 2 cubed times 3 times 5 squared. And if we add 1 to each of the exponents, we get 4 times 2 times 3. So 8 times 3, which is 24. So the number of total divisors is 24. And to account for 601, we can just subtract 2. And our final answer is 22. Okay. D of 600 is how many divisors 600 has. D of O of 600 is how many odd divisors 600 has. And D of E of 600, or alternatively, D sub E of 600 is how many even divisors 600 has. What is the value of D sub O of 600 times D sub E of 600? Okay, so we have to find how many odd divisors 600 has and how many even divisors 600 has. Okay, so for 600, let's go back to original prime factorization. That was 2 cubed times 3 times 5 cubed. And to find the odd numbers, the odd divisors, sorry, we can just ignore the even and only count the odds. So this is going to be 3 to the 1 times 5 to the 2. That's going to be 2 times 3. So there's 6 odd divisors. And if we want to find the number of even divisors, then we just subtract this from the total number. Okay, so we had originally 24 divisors. So let's subtract 6. That means there's 18 even divisors. And the problem asks us to multiply these, so it's going to be 6 times 18, or to do it more quickly, 6 times 6 times 3, which is 36 times 3, which is 108. Our answer is 108.